have a look here. We'll pause here. In class, we would have paused, and then you can scan these QR codes to get a brief tutorial on how to calculate logs using your calculators, your TI-84 or your Casio. You will need them. Not all logs can be evaluated by hand. You'll need a graphing calculator or a calculator. Okay. Let's do some work on evaluating logarithmic expressions. Before we learn how to transform them and then do applications and problem solving, we need to know how they actually work. Okay. First thing, if there is no base c written in the log expression, the base is assumed to be 10. This is called a common log. It's a common log because it's so common that we don't write a 10 in there. It's kind of like equivalent to like a square root. For the index, we don't write the 2 because we do square root so often that we write that radical sign without the 2, and that's assumed to be a square root. So same thing with logarithms. If I write a log like this, log of x, that's assumed to be log base 10 of x. And we know log of 100, if we convert it, that's going to be equal to 2. The log button, be careful, on your calculator is programmed as base 10. Be very, very, very careful. If the base is not 10, then you must use a special function on your calculator. Pause here and view using the QR code, okay? You need to know how to do this before moving on, okay? Here, I'm going to write this over and over again until you get used to this. This is something new. The logarithm is the exponent of the base that gives you the argument. The logarithm is the exponent of the base that gives you the argument. That assumes that you know this thing. You know what the pieces parts are. That's the base, exponent, that's the argument. Assuming you know all that, right? Remember this. Logarithm is the exponent of the base that gives you the argument. Logs can be evaluated by converting them to exponents and then changing the base if necessary. We'll go over some examples. Example 1, log base 3 of 81. Evaluate the logarithmic expressions without a calculator. The logarithm is the exponent of the base that gives you the argument. Okay, exponent of the base. The base is 3. What exponent do I put here to get 81? The logarithm is the exponent of the base that gives you the argument. Well, that's 4. Okay, so instead of writing all this, right, that equals 4. So I'm doing this. 3 to the 4th equals 81. Next one. What exponent do I apply to the base to get 64? 4 to the 4th. Oops. Oh, my goodness. 4 to the 3rd. 4 times 4 is 16 times 4 is 64 equals 64. So this is equal to 3. The log base 464 is 3. How about log base 7 of 7? What exponent do I apply to 7 to get 7? 1. So that's equal to 1. Log base 12 of 1. Not a trick question. Do exactly as the logarithm laws say. The base is 12. I'm going to equal 1. What exponent do I apply to 12 to get to 1? Well, exponent is 0. So log base 12 of 1 is 0. Example 2, evaluate the logarithmic expressions without a calculator. Same deal. This 2, that's a coefficient. I'm going to leave it off to the side. 8 to what exponent gives you 512? Pause here, think about it. This is without using a calculator. If you think the answer is 3, then it is. Log base 8 of 512 is 3. 8 to the 3rd is 3. So I write this part as 3. And that equals 6. Same thing. 2 to what exponent equals 1 over 32? That's what we're thinking, right? So I'm going to rewrite this as 1 over 2, okay, to the 5th. Okay, that's 1 over 32, or 1 over 2 to the 5th, or 2 to the negative 1 to the 5th, or 2 to the negative 5. So this is negative 5. So log base 2 of 1 over 32 equals negative 5. Oh, what about a radical? So if I rewrite this, log base 5 of 125 to the 1/2. Log base 5 of, well, What's the square root of 125? Well, this is 5 times 5 times 5, or 5 cubed to the 1/2, log base 5 of 5 to the 3/2. Okay, 5 raised to what exponent equals 5 to the 3/2? Well, 3/2. Okay, and as we go along, check these on your calculator. When we're doing these for the first time, it can get a little confusing. You're like, how does that even work? Okay, all right. Helpful identities. Evaluate the logarithmic expressions. Log base b of 1. Well, take the base, apply the exponent. What exponent do I apply to get the argument? Take the base, apply the exponent to get the argument. Well, what does this exponent have to be to get 1? Well, 0. So log base b of 1 equals 0. How about log base b of b? So I take the base, apply an exponent, I'm going to get the argument. Well, what do I do here to get b? Well, that's just 1, folks. So log base b of b equals 1. Okay, so a couple of helpful identities. You see what's going on here. Next page. Example 4. Logarithm is the exponent of the base that gives you the argument over and over again. Going to haunt you in your dreams, okay? I'm going to keep putting that on there. Evaluate the logarithmic expressions without a calculator. What is going on? Oh, let's see. Log base 5 of 0. If we think about our properties of logarithms, I take the base, apply an exponent, I get 0. Is there any way I can apply an exponent to 5 and get 0? No, right? Try it. There's nothing, right? So this is undefined. This is not allowed, right? And we do have a stipulation here that that value, right? If you look back on your notes, what's that value called? Okay, if you look back on the notes, that value for the argument. Okay, first of all, the restrictions on the base were good. It's c is greater than 0. C does not equal 1. Okay. The expression must contain an argument, right? The argument cannot be 0. Okay, you cannot evaluate the logarithm of 0. Okay, so be careful with that. How about 0? I take the base, log base 0 of 5. I take the base, I apply an exponent, I get the argument. Does this make sense? What exponent can I apply to 0 and get 5? Well, there is none, so no. This is undefined as well, okay? Also, if you remember, we go back to our notes, the restrictions on the base, c must be greater than 0, and c cannot equal 1. Okay, so this doesn't meet our test here. The base, c cannot equal 1 to be a logarithmic function, and c must be greater than 0. Okay, it's not greater than 0. All right, log base 3 of -9. Let's see. I take the base, I apply an exponent, I get the argument of -9. Can I take a positive base, apply any exponent? A rational exponent, integral exponent? Can I ever get a negative number? No. So this is undefined as well. Okay. Okay. This also violates this part here. So the domain of logarithmic functions, which we saw in our putting it together thing a page ago, the argument is always restricted to values that are positive. So x is greater than 0. So this cannot happen, and this is the reason why. Okay? So those are 3 special cases. Investigate. Evaluate log base 5 of 50 by converting to an exponent. So take the base. What exponent do I apply to get to 50? Well, there is such a number, but like it's not going to be a whole number, right? So this is where you need a calculator. What problem do you encounter? I need a calculator. Okay, so back up here, take log base 5 of 50. So you've looked at the QR code, right, to understand how to do. So remember that log button on your calculator? That is a common log. That's base 10. This is base 5. Be careful, right? So you need to do the change of base thing. Your TI-84 and your Casio FX9750G3 has this function built in. So I have my TI in front of me, log base 5 of 50, and let's put it to the nearest hundredth. That's 2.43. So what does that say? 5 to the 2.43. We're approximating here, but it's going to be roughly 50. Okay, and that's what we're doing here. So some of these you do need a calculator. Change of base identity. The base of any log can be converted to a different base using the following change of base identity. Log base b of c. The c goes here into the new part here. The b, the former base, becomes another argument in the denominator, and then you choose any base a. Right, where a is not equal to 0, a is greater than 1. Okay? Here's an example of why it works. If I have log base 4 of 4096, right? If you go, if you do that calculation, log base 4, what just happened here? Log base 4 of 4096, that is equal to 6, right? So this is equal to 6. But if we do this, folks, 12 divided by 2, that's also equal to 6. Well, 12, log base 2 of 4096 is 12. Check it on your calculator. The 2, log base 2 of 4 is 2. If I divide those two, I'm going to get 6, right? So this is 12. This is 2. Well, look what's going on here. This is the change of base identity exactly as it's written, okay? Okay, read this important note. Some calculators don't have the change of base identity, like the feature built in. So you have to do this calculation every time you want to do a log that's not a base 10. Okay, so if that's you, a TI-83, some of the older calculators, you have to do this thing. Okay, so have a watch of the video. With your knowledge of logarithms, you should understand what is going on here. Okay, so get that resolved right now. Okay, change the following into the base indicated. So if I take log of 6, log base 6 of 216, to base 3, I'm going to use my change of base identity. So log base, okay, to base 3 of 216. Remember that 216 comes over here. I create a denominator, log base. I want 3 again. And I take this base and I make it the new argument. Okay. If you do this, pause here, do this on a calculator, and make sure it equals this, right? So 6 log base 6 of 216, this is 3. If you do this on your calculator, this equals 3, okay? Change of base identity works. Log base 4 of 50, I want to change it to base 8. Log base 8 of 50, so that 50 comes over here. Log base 8 of 4, so that 4 goes over here, okay? Log base 4 of 50, rounded to the nearest hundredth, 2.82. And then if you do this calculation, that's 2.82 as well, okay? Okay. Next page, folks. Okay, evaluating logarithms with a calculator. To evaluate a logarithm with a calculator, use the change of base identity to change the log to base 10. That's if you don't have that function on there. But if your calculator has the feature where a specific base can be entered, you don't need to use the change of base identity because it takes a lot of keystrokes. But just giving you some advice, it's good to practice both ways because it helps you understand the change of base identity and how it works. Use the change of base identity to evaluate the logarithmic expression on your calculator, then evaluate without a calculator to verify the solution. So change of base identity, log base, you can pick any base. Let's do log base 11 of 1024 divided by, same base, log base 11 of 4. Okay, that 1024 goes here, the 4 goes here. Choose whatever base you want, okay? Oops. Okay. All right, so I'm going to do log base 11 of 1024 divided by log base 11 of 4, and I get 5. Well, that's saying here, what's log base 4 of 1024? If I think about it, 4 raised to what exponent gives me 1024? I bet it's 5. So this equals 5. Okay? Same. All right. 3 times log base 2 of 32. So 3 times, I'm going to leave that 3 alone, log base, I don't know, 5 of 32. Remember, you can choose any base here. Log base, let's do this just to show you. The easy way is just use common logs because the button's built in. So log base 10, but I'm going to just write it as log of 32. That assumes it's base 10. Log of 2. Okay, the 32 comes here. The 2 comes here, and then no base written, that assumes 10, right? So common log of 32 divided by log of 32 divided by log of 2. 5, and then I have to multiply by 3 times 3, 15. 3 times, well, log base 2 of 32, 2 raised to what exponent, so off to the side, 2 raised to what exponent equals the argument, 32? Well, that's 5. So bring this down, 3 times 5 equals 15. Same. Okay, change of base identity. I'm just going to use common logs now. So common log of 1 over 27 divided by common log of 3. So common log of 1 divided by 27 divided by common log of 3. Negative 3. Well, this one, 3 raised to what exponent equals 1 over 27. Remember, 1 over 27 is 3 to the negative 3, folks. Okay? So that has to be negative 3. So log base 3 of 1 over 27 is negative 3. And change of base identity, same. Okay, this one, negative 1 times common log of 1 over 243 divided by the common log of 7. So the log of 1 divided by 243 divided by the common log of 7. Oh, shoot. Sorry about that, folks. That should be 343. My apologies. Okay. So the log of 1 divided by 343, log of 1 divided by 343, divided by log of 7, negative 3. Okay. And then times negative 1, don't forget about that, that's positive 3. So if I have negative 1 times, let me do this off to the side. So just this part, 7 raised to what exponent equals 1 over 343. If you notice 343 is 7 cubed, so I can think of it this way. 7 raised to what exponent equals 1 over 7 cubed, or 7 to the negative 3, and that's negative 3. I multiply by negative 1. So this log base 7 of 1 over 343 is negative 3. So I have positive 3. Same. Okay, log of 1 over 1024, the square root of 1 over 1024, divided by log of 2. The log of, let's just do this on a calculator. So we're doing log of the square root of 1 divided by 1024 divided by the log of 2, negative 5. Okay, let's evaluate this. This part, I take the base 2, what exponent it's raised to gives me square root of 1 over 1024. Wow. Okay. Folks, this looks like something I need to convert this to a radical, or sorry, to an exponent. So that's 1 over square root of 1024. That looks like it's a perfect square. So 1020, if I do 32 times 32, that's 1024. So this is 1 over 32. And that's 1 over 2 to the 5th, which is 2 to the negative 5. So this has to be negative 5. So log base 2 of square root of 1 over 1024 is negative 5. And when you do this on a calculator, that's negative 5, same. Okay. Log base 7 of 49 to the negative 5. So change your base identity. Log of 49 to the negative 5 over log of 7. Log of 49 to the negative 5 divided by log of 7. Hang on. Log of, you got to be careful with your brackets, really careful here, to the negative 5, and then I'm going to close it with big brackets, not small brackets on the exponent, divided by log of 7. I got negative 10. So 7 raised to what exponent equals 49 to the negative 5th? Wow. This one, 7 squared to the negative 5, that's 7 to the negative 10. So this has to be negative 10. Therefore, log base 7 of 49 to the negative 5th is negative 10. And we prove that's the same with our change of base identity. Okay, pause here briefly. Remember for tomorrow's lesson, right? Look at these because we're going to graph logarithms, transformations of them. So watch these videos to get an idea of how to do it on your calculator. It'll make tomorrow's lesson a lot faster. Okay, the next one. All right, next page, folks. Evaluate, no calculator. What is going on? Now I have exponents that are logs. How is this even possible? Okay. Evaluate, no calculator, then with a calculator. Don't put your calculator away, okay? Use what you know about logarithms here. The logarithm is the exponent of the base that gives you the argument. Exponent of the base that gives you the argument. Let's convert this to a logarithm, right? Logarithm is the exponent of the base that gives you the argument, okay? But if we think about it the other way, I'm referring to this chart here, all the way back. This one. This is the exponent from my exponential expression. This is the base from my exponential expression. This is the argument, which is also the argument on the exponential expression. That's what I'm referring to. Go back and let's think about this. Don't make this more complicated than it should be, okay? I'm going to convert this into logarithmic form. So log, what's the base? 5. Okay, log base 5. I'm going to leave a big blank here, okay? I don't know the argument, right? But I know the exponent. What's the exponent? It's this weird thing. A logarithmic expression can be an exponent. So log base 5 of 25, okay? We're using the knowledge we have of how to convert from exponential form to logarithmic form. So this is how you write this exponential form in logarithmic form. Okay, 5 to the exponent log base 5 of 25. The base is the base, so log base 5 of what equals the exponent, log base 5 of 25. Well, this obviously has to be 25, right? Another way to think about it, folks, 5 log base 5 of 25. Look at the exponent just by itself right here. Okay, look at that exponent. What is that? Log base 5 of 25. Well, that's 2, right? This whole exponent is really just 2 in disguise, and that's 25. And that's what we found for our argument. Okay. I don't know why I just put 3 of the same thing in here. Yeah, that's clearly a typo. I'll fix that. Okay, but you get the idea of how to do these, right? What's an example I can show you on the fly here? Uh, I mean, you can do 6 of log base 6 to the 36. You can use the same type of argument. The thought process, well, 6 to the log base 6 of 36, that is 2, so that's 6 squared equals 36, okay? Based on your observations, what is the value of a log a to the exponent log a of n? Convert to logarithmic expression, right? So I take the base, so I'm going to make a logarithm out of it. So I take the log, the base is the base. So there's my base a. What is the argument? I don't know. The exponent is a result of a logarithm, so I write it exactly like this. Now, let's take a look at this. Log base a, log base a. Well, n, it must be n. Okay, so a log base a of n equals just n. Okay, what is the value of log base a to the log base a of a to the n? Well, the base is the base. Let's convert it. So a to what exponent equals the argument, a to the n? Well, that has to be exponent n, so this equals n. Move on. Next one.